has tensor cores. I just talked about a whole new line of PCs. Agriculture equipment, manufacturing equipment, heavy industry equipment will all be agentic. You'll even have a little agentic helper for yourself. Even your base stations, the radio stations of the future, are going to be agentic. Understanding traffic and thinking about how to coordinate with the other base stations so that you could use as little energy as possible, increase the utilization, the efficiency of the spectral efficiency. And so everything will run agents. Today, NVIDIA is largely in the center, but I am pretty certain that there will be tens of billions, hundreds of billions over time of agentic systems, agentic computers that are going to be running around the world. The biggest problem is data. In the case of language models, all the English and all the language that we have on the internet that we trained on was from the perspective of us. We wrote it and we're reading it. However, in order to create data for AI, robotics, it has to be in the perception, the perspective of the robot. And most of the world's video data is from a third person, not first person. And so agentic systems, robotic systems, physical AI, the data is the hardest problem. You've seen us move up this ladder. We started with teleoperations, which is basically human demonstration. This is no different than the big breakthrough of reinforcement learning, human feedback. Then we use simulation. This is where Omniverse comes in. This is no different than reinforcement learning, verifiable rewards. Okay? And so we use these systems to bootstrap the AI model, the physical AI model. Eventually, we're able to learn from third person, reprojecting it into first person, and now, eventually, through bootstrapping, we have a world foundation model that can understand the physical world from any perspective you want. Third person, first person, outside in, inside out, doesn't matter. This is a big breakthrough indeed. And today, we're announcing Cosmos 3. Cosmos 3 is the frontier of physical AI. We are at the frontier with language models. There are so many people working on it. However, in physical AI, we are absolutely the world's best. I am so proud of the team for doing this. This is the foundation model for all of your work. Whenever you want to create a robot, whenever you want to create a factory robot or a robot that works in a factory, any kind of robot that involves physical world, you now have a companion, a Cosmos 3 that can understand and reason. It can generate. It can simulate in the loop. It can even be the policy itself. It is on the top of leaderboards all over the world. I am incredibly proud of Cosmos, and today we're announcing Cosmos 3. Let's take a look.
The real world is infinite and unpredictable. Physical AI needs data, but real-world data is impossible to scale. For physical AI, compute is data. This is Cosmos, an open frontier omni-model for physical AI, built on a new mixture of transformers architecture. Pixels, action, sound, and language flow into the autoregressive transformer, which reasons, plans, and instructs the diffusion transformer, which generates what comes next. Developers post-train Cosmos across embodiments and use cases. As a VLM, Cosmos watches the physical world, understands what's happening, describing scenes, and flagging what matters. As a world model, Cosmos generates physics-accurate synthetic video from an image, text, or video. As a simulator, Cosmos closes the loop for policy training and evaluation. And as the foundation of NVIDIA OmniDreams, an action-conditioned world model, Cosmos predicts the future, frame by frame. Post-train Cosmos, and it becomes a world action model. Perceiving, reasoning, planning, generating actions. For robots of every kind. For everything that moves. A new kind of data, a new kind of teacher, generated by compute. Cosmos, the foundation for developers of the age of physical AI.
It takes data plus compute, gives you AI. Now that we have AI, compute is data. And so use Cosmos 3, train a whole bunch of AI models. Cosmos is such an incredible open model system. It's exactly the same as Nemotron. We open the model, we open the data, and we even opened how we trained it so that you could enhance it for yourself and turn Cosmos into your proprietary model. We have such incredible partners working with us in so many different industries. Now, the model itself is the most, of course, the most understandable part of the AI stack, but the AI stack is very complicated. It has generators, the model, simulators, and the runtime. Just as it is for agentic systems, these cars, or essentially a physical AI, agentic robot that is an autonomous vehicle, has also this complicated stack. Today, we're announcing Alpamayo 2, an open model for self-driving cars. We're working with car companies across the world. If you look at these brands that have signed up for the NVIDIA Hyperion, that are building NVIDIA Hyperion cars, this represents about 80% of the world's cars. The manufacturers represent 80% of the world's cars. We are going to have a whole lot of NVIDIA Hyperion systems that are able to run Alpamayo or anybody else's AV stack. We are also connected into mobility services. Approximately 97% of the world's mobility services are connecting with us so that when we deploy Alpamayo on the Hyperion runtime with the Halos operating system, we will be able to connect to all of these services across the world. Let's take a look at this.
Hey Mercedes, let's go to my favorite sandwich shop.
Routing to your destination. Lane is clear, pulling out to start drive. Nudge left due to the stationary lead vehicle ahead blocking our lane. Slow down to stop at the stop sign, controlling the intersection. Stop to yield to the pedestrian since the person is in our lane. Yield to the cut-in vehicle from the left. Nudge left to clear the stopped vehicle blocking on the right. Keep distance to the cut-in vehicle since it is merging into our lane. Nudge left due to the stopped van blocking the right side of our lane. They are in our lane. Pedestrian crossing ahead. Stop to keep distance to the lead vehicle. Keep distance to the vehicle directly ahead in our lane. Keep distance to the vehicle directly ahead in our lane. Stop to the stop sign since the intersection is controlled by a stop sign. Stop to yield to the cross traffic since the vehicle is crossing ahead. Keep distance to the lead vehicle. Nudge left due to the truck blocking the right side of our lane. Nudge right due to the truck blocking the left side of our lane. Nudge left due to the truck blocking the right side of our lane. Your destination is on the right.
Alpamayo, the world's first reasoning autonomous vehicle. If you let it talk all the time, it will drive you crazy. But we're very happy that it's talking to itself all the time. That's called thinking. And so Alpamayo is a reasoning car. The technology that we've created also applies to humanoids. Of course, there are many new breakthroughs that has to happen. The NVIDIA Isaac GROOT is our humanoid robotic stack. Model, data generation, simulation, the runtime, including the operating system. This represents GROOT platform, the Isaac GROOT platform. Every one of our systems, as you can see, the exact same pattern, whether it's agentic system for the cloud, agentic system for the PC, a robotic system for a self-driving car, a robotic system for a human or robot, all the same. And of course, in every single case, we build everything completely. We build everything vertically, completely, integrated with co-design, extreme co-design, and then we open it up for everybody to use whichever part you like. And whatever you want to use, we even help you modify. But the one thing that is missing is we need a reference platform for robotic systems. These robotic systems are so complicated, so many motors, so many sensors, so fragile, and yet we need to have a way to deliver these reference platforms just like we do with PCs and DGXs and clouds and self-driving cars. We now are going to do it for robots. Today, we're announcing the NVIDIA Isaac GROOT, a reference humanoid robot, all fully integrated. 25 degrees of freedom on each hand, made by Sharpa. 31 degrees of freedom on the robot. 6 feet, 150 pounds. Just like me. The first number is shorter, the second number is bigger. Otherwise, pretty close. And this platform runs the new Thor and our entire software stack. Data generation stack, data simulation stack, the runtime, all integrated into a robot that is designed for everyone to use. Now, we built this for higher education and university researchers because for them to build this is insanely hard to do. And so let's take a look at that.
The next leap in AI is general-purpose robots, humanoids. But building one is hard. Every team starts from scratch, stitching together simulators, teleop systems, data pipelines, and training infrastructure. Months of setup before research can start. NVIDIA Isaac GROOT, an open development platform for humanoid robots. Open models, simulation and training libraries, and data generators. Plus, the robot computer. Fully pipe clean, ready to go in hours. First, set up the simulation environment in Isaac Lab. Capture demonstrations with Isaac Teleop on a real or simulated robot. Generate synthetic data with Omniverse and Cosmos, scaling one demonstration into thousands. Train policies, evaluate them in Isaac Lab Arena. Deploy through Isaac Ross, running on Jetson Thor. Every element, modular, open. Use ours or swap in your own. GROOT is powering robotics research across every discipline, for every domain, from research labs to factory floors. One open platform. And now, a new addition. Isaac GROOT Reference Design Robots. Built on NVIDIA's open platform. Ready for frontier research, for any lab, anywhere. The age of robotics starts here. NVIDIA Isaac GROOT.